Soil resistivity is an important parameter in the design and analysis of grounding systems, and it is essential to measure and understand soil resistivity to ensure the safety and reliability of electrical systems. Soil resistivity is expressed in ohm meters and is a measure of the resistance of the soil to the flow of electric current. The resistivity of soil is influenced by various factors including soil type, moisture content, temperature, ionic content, and compaction. A lower soil resistivity means that the soil is more conductive and is better able to conduct electrical current. This is desirable in grounding systems where a low resistivity is required to ensure that electrical charges are safely dissipated into the earth. Conversely, a higher soil resistivity means that the soil is less conductive and is less effective at conducting electrical charges. This is not desirable in grounding systems as it can result in higher resistance, leading to increased risk of electrical shock and other safety hazards. Soil resistivity can be measured using various techniques such as the 4-point method, Schlumberger method, and the fall of potential method. Measurements are typically performed by placing electrodes in the soil and measuring the potential difference between them. This potential difference is then used to calculate the soil resistivity.